Hello everyone, my name is Pandya Kushi. Now we will discuss about digital signal transmission and bandwidth requirement. So in this video, we will firstly discuss about what is digital transmission, and its means two types. First is baseband transmission, then broadband transmission, and its bandwidth requirement. So what is digital signal transmission? Digital signal contains only zeros and ones in its signal, and as we know that in our environment we mostly contains analog signals, but digital signal has more advantages than analog signals uh, in the case of transmission, because to store digital signal is easy, and noise affection on digital signal is also less than analog. So we need to find the way to transmit this digital signals. We have many ways, but we can say that majorly these two ways are used, or these two approaches are part of that. So first is baseband transmission and another is broadband transmission. Baseband transmission, the word contains baseband. Base means original signal, and original signal is what? Digital signal. So baseband transmission contains digital signal over a medium, over a channel. Because for transmission of any signal, we require an medium or a channel. So during this baseband transmission, only one signal is transmitted from the transmitter side, and that signal only we are receiving at the receiver side. So baseband transmission is bidirectional, because whatever signal we transmit, that signal only we are receiving at the receiver. So if we want to get back to that signal from the receiver side, so we can easily get that. And for this transmission, we required low pass channel for receiving. A low pass channel means uh, bandwidth which starts from 0 and end up to certain value. This we can call as a practical bandwidth, or ideal bandwidth we are considered as 0 to infinite, but there is no low pass channel as 0 to infinite, so we are considering that 0 to certain value, that is low pass channel, and this baseband signal are transmit over this low pass channel. Baseband transmission contains the time domain multiplexing. Like you can see here that only one signal is transmitted over different times from the transmitter to receiver. So next we will discuss that low pass channel and its two types. Two types are the first with narrow bandwidth and another one is with wide bandwidth. Narrow bandwidth, or we can say limited bandwidth. As you can see that this is 0 to f1. F1 means a certain amount of frequency, and from this bandwidth only we have to transmit our digital signal. And here 0 to f1. But in wide bandwidth and narrow bandwidth, value of f1 is less in narrow and f value of f1 in wide bandwidth is larger, as the word says that. So the detail about this, the first image is about wide bandwidth channel. This is our digital input signal, and this signal we have to transmit through this channel. Here f1 and f2, because we are transmitting our signal from low pass channel, so here the bandwidth is from 0 to infinite, but 0 to infinite is the ideal bandwidth, so we can consider it only up to 0 to any f value. This signal is passes between f1 and f2 channel, and at the output side we are not receiving our original input data, but we we are also not getting more distortion in our signal. And this wide bandwidth channel transmission is only possible up to short distance, because as we can see that input to signal is not perfectly returning at the receiver side, uh, and so that as distance in can increase, attenuation, which is which we can define like as distance increases, distortion in the input signal is happens and we are not able to get proper output. So this is like a wide bandwidth, and downward this picture is about narrow bandwidth. And in a narrow bandwidth we are taking certain harmonics of the digital signal. As we are transmitting this digital signal in a form of 0 1 0, and after this we are also having 0 1 0, then 0 1 0. So we are taking some part of all digital signal, of full digital signal. 0 1 0 is the only part, and we are getting that analog signal for the transmission, because in a narrow bandwidth, if bandwidth of the channel is less than input channel, so we are not able to transmit the full digital signal. So we need to take a part from the input signal and then transmit to the channel, and again at the receiver side we need to collect all those harmonics and get output signal. As we know that bandwidth is directly proportional to the bit rate, so as the bandwidth is higher, uh, faster transmission can be happened. Higher bandwidth means we are only taking part n by 2 of digital signal. Instead of n by 2 we can get 3n by 2, we can get 5n by 2. So we receive the signal faster from the input side. This is about baseband transmission with a limited bandwidth. Then we will move towards the broadband transmission. Broadband transmission means we can transmit more data in a same time, multiple data in a same time. As you can see here, the signal 1, 2 and 3 contains different data, but we are transmitting them in a single time only. And for this transmission we are using band pass channel. For the first one we were using low pass channel. So what is band pass channel? Uh, if a certain amount of frequency f1 to f2, low pass channel starts from with 0 to f1 and band pass channel is starts from f1 to f2. Now let us see that some difference between baseband and broadband. Major difference between these is in baseband we are transmitting only one signal through the medium, and in a broadband we are transmitting multiple signals in a channel. Another one is a medium for the transmission. For baseband transmission we can use twisted pair cables, coaxial cables, and for broadband transmission we can use fiber optic cables, coaxial cables and radio waves. And baseband another difference is it uses time division multiplexing, and broadband signals are using frequency division multiplexing. That more frequency at one time, or we can say more number of data, multiple number of data at one time. Application these signals are used in Ethernet LAN networks, and broadband signals are mostly found in cable and telephone networks. Same thing, that one signal and multiple signals. So that's it about today. Thank you.